Hey, welcome back. This is day 2 of standard deviation part 2. Yesterday, boring, sorry, I just took notes. Today we're going to get into actually how to do it, So we kind of talked more on the surface yesterday. We'll go through an example of test scores. I don't know, this comes from the worksheet, so open the worksheet, take a look at it. Question number 1 looks like this. I don't know if these are percents or what, because if they are, they're just awful test scores, and then we're going to have the grade on a curve. We'll talk about that too. That'll be in your packet. So we'll be back in the packet in a little bit. So let's just go through this example first, okay? Over here, we're going to look at what we know how to do from previous lessons, like last year. Mean, median, mode, interquartile range, those kinds of things. So take these 1, 2, 3, 4, 5, 6, 7, 8, 9 test scores and find the average or the mean. Go. Add them up, divide by 9, you get 49.56, okay? Next thing, the median. We can work in, like that. I know if there's 9 numbers, the middle number would be the 5th number. So 1, 2, 3, 4, 5. That's the median right there. Circle it, put an M, or just write the word median above it. And that's at 52. Do you remember what the mode is? I bet you do. It's the one that occurs most frequently. There's no repeats except for 54, so 54 automatically becomes the mode because it's the only one that occurs twice. Now, interquartile range, for this, take the median out of play, okay? You now have 4 numbers over here and 4 numbers over here. To find the interquartile range, you got to find the quartiles. So in between 42 and 48, we have the first quartile of 45. Okay, circle that, Q1. And then over here between 54 and 54, well, that's just 54. That's Q3. So the interquartile range is from 54 to 45, which is 9. Okay. So that's stuff that we talked about last year. We also did box and whisker plots with these guys the year before and last year. Split them up into percentages of 25%. This is 50, 75. This is the whole thing. Each compartment is 25% of your data. Okay. But now let's go a step further and analyze it using standard deviation to look at how far is each point from each other, from the mean, and what does that mean for your outliers. Okay. So all we have to do for standard deviation is the 5 things we went over yesterday. Maybe you didn't catch all 5, but here's the first one. It's find the mean. Oh wait, we've already done that. It's 49.56. So let's just bring that over. .56. Okay. Number 2, we need to figure out how far away is each data point from the mean. So we're going to take the difference of those. So we're going to go with, let's start here, 37 minus 49.56, and that's going to be a negative value. You're going to subtract each one of these, all 9 of them, from 49.56, okay? You know what? Let's go ahead and round that to 0.6. Let's do it this way. All right, fast forward through and go. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I mean, I started using calculator for some of it, and then I started using my brain, but that shouldn't be that hard to subtract each number from the mean. Now, in the step 3, we're going to take all of those differences, and we're going to square each one so that distance is never negative, right? So if you want distance from, you could do the absolute value as well, but we're going to square all of these, average it, and then take the square root. So let's go ahead and just square each number in the calculator, okay? Go. Done. Always paranoid about missing a number. Make sure you count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we've got all 9 of those. Now notice it took the liberty of putting plus signs in between all of those squared differences. Okay, that's the level we're at right now. The mean, the difference from the mean, the squared differences. Okay? We're going to average those together. And at this point, the number that you draw a line, And the number that you divide by is either going to be the whole number of items in your data set, which is 9, or 8 if it's a sample. So I'm going to assume that this is for an entire population. Directions say population standard deviation, which means, yes, you're going to divide by 9. Okay, so this number is going to be a 9 right here. So in the calculator, add up these numbers and divide by 9. We have arrived at the variance. Okay, when you take all your squared differences and you average them together, I got 34.027 if I round. It's actually a repeating 6, but we'll just keep it a 7. That's your variance. And you're one step away from finding the standard deviation, as you can see. Because we wrote yesterday, the definition of standard deviation is the square root of the variance. So we just got to take the square root of 34.027. And that's going to be equal to our standard deviation. You guys remember the Greek letter? Sigma? I have a hard time drawing it, so I usually draw a little oval first and then make it look like an R. Okay, so that's going to be approximately 0.027. 5.8. Let's go with that. Okay. We have our standard deviation number. Let's check that over here. They got 5.83, but we rounded back here. Remember, we rounded the mean to 0.6, so we don't have 5.83. That's okay. Actually, I do have 5.83. It's like it's right there. Now, what do you do with that number? Okay, that's the next thing. That's great that you have a standard deviation of 5.8. What does that even mean in terms of this data set? Well, we have to start to map things out. So we're going to do that over there. Okay. Okay. Oh, hold on. Hey. Yeah, you've hit like 5 home runs. You know, that's a lot. So could you like not hit a home run this time? Yeah, okay. I won't go yard. You promise you won't hit I'll try to keep it in the ballpark. Just don't go yard, okay? Just promise. You're going against muscle memory here. All right, bring it. Still not going to tell you what's coming. Okay, here we go. Oh, thanks, Mini-Me. Feel like it doesn't really hurt like here or here, but right in here. The standard deviation is 5.8. So I need you to map this out on a piece of paper, maybe that would help. And the standard, the mean, well, sorry, we'll put the mean right here, which is 49.6. Okay, and I've got 1 sigma, 2 sigma, 3 sigma, -1, -2, -3 going that way. To get to 1 sigma, you just got to take 49.6, which is the mean, and add 1 standard deviation to get to here. So 49.6 plus 5.8. Okay, do that. Now to get to 2 sigma, you just keep adding the standard deviation. So 55.4 plus 5.8, 61.2. And so on. Plus another 5.8, 67. To go backwards, you just subtract. So you're going to take the 49.6 and subtract 5.8. and you're at 43.8. And keep subtracting this way. That's 38 minus 5.8 is 32.2. Now, if you recall from yesterday's notes, 68.2% of the data on average falls between 1 and -1, or within 1 standard deviation of the mean. So all we're going to do is place each data point in its appropriate location where it would be in the bell-shaped curve. Okay, let's start with 37. 37 is in between 32.2 and 38, so the 37 would go right here. Okay, so we have one data point between -3 and -2 sigma. Okay, the 42 is in between 38 and 43.8, so the 42 goes here. And we've got a 48, which would be in between those two. Next, 51 is right here. And then we've got a 52 and a 53. Okay. We've got two 54s, which both fall in that category. And then last, we have a 55, which is, that's also there. It's less than 55.4. Check that out. You have 6 of the 9 data points right here in this group, okay? 7 of the 9 are in between -1 and +1 sigma, or within 1 standard deviation of the mean, positive or negative. 7/9 as a fraction, well, 7/9, as a decimal is 0.7 repeating, so as a percent is 77.8%. Okay. I said it's 68.2, that's on average, there's only 9 data points, so that's pretty close, but it's not going to be exact, okay? Look at this guy over here. He's all by his lonesome. I said anything that's outside of 3 standard deviations is definitely an outlier. Anything that's outside of 2 is borderline outlier. Sometimes it's a judgment call, okay? But I would say it's close, but we can still, it's not like it's so far away from everybody else outside of 3 that you would say, wow, you're really far out there, okay? So this is the process I want you to get used to, is taking the data set, analyzing it, coming up with a standard deviation, okay? Mapping out your data points. And you know what? Standard deviation calculators on the website, the one that I have for you, does this for you, which is nice, okay? So that's what we're gonna do now. We're gonna go to back to the website, click on the standard deviation calculator, and get out the last page of your notes. And I'm gonna hand over the rest to Minnie.
Hey guys, so here's what I got from the website. I've got yesterday's worksheet for notes, the last page, fair or unfair, turn to that page. Over here on this side, I've got the agenda for the day or the website, and I need you to click on standard deviation calculator right there. It's the black button, and you'll notice that this pops up. All I need you to do now is to transfer these 20 test scores from the worksheet, probably just copy them, control copy, and paste them right there. Boom. And you'll notice that it just autofills with everything that you need. Okay, so you've got a count of 20, which means there's 20 test scores. You've got the sum and the average. So the average is 82.8. That goes right here. Okay, so go ahead and type in 82.8 or write it in if you printed it out. And then if you sift through the rest of this data, you get everything we did in today's lesson. You get the differences, you get the squared differences, the variance, which is the average of those, and then the square root of the variance, which is the standard deviation of 9.17, 9.2. So fill that out over here, mean, variance, standard deviation. Now, put the mean of 82.8 right here, and then continue to add the standard deviation of 9.2 once, twice, 3 times in those boxes, then go back to the mean and subtract the standard deviation going this way, okay? And what I want you to do, that's pretty much it, only for this one last little twist, and this is grading on a curve. So if these were the 20 test scores for this class, I'm going to say now that any test scores that fall in above 2 sigma get an A. Anybody above 1 sigma, in between 1 and 2, gets a B. Anybody in the middle here gets a C. Okay, this group gets a D, and anybody below -2 sigma gets an F. Does that sound fair? Let's discuss. We'll talk more about it tomorrow. Have a good day.